Everyone, Mr. Abeto back for lesson 5 of Unit 9. This time we're going to be talking about the reciprocal functions, okay? So to get into these, let's just remind ourselves first the ratios for each trig function from SOHCAHTOA. We know that sine of theta is always opposite over hypotenuse. The cosine of theta is adjacent side over the hypotenuse, and the tangent side is always the opposite over the hypotenuse here. Each of our basic trig functions, sine, cosine, and tangent, also has a reciprocal function that it's paired with, in which reciprocal only means, remember, you just flip the numerator and the denominator of a ratio, right? So it's the same idea with these reciprocal functions. You just take each ratio and you flip it to its reciprocal. The secant is the reciprocal of cosine. The cosecant is the reciprocal of sine, and the cotangent is the reciprocal of tangent. And we definitely need to remember what goes with what, because of course they're going to have different values if we mess that up. Something that always sticks out in my head is that like secant and cosecant don't go with like the co part for sine and cosine, and secant and cosecant flip, right? So like cosecant goes with regular sine, right? And secant goes with cosine, and then tangent's its own thing, right? It's always tangent, cotangent that they do that with, right? But what does that mean practically then? Well, it's pretty easy for us. We just take our values for sine, cosine, tangent, and then if we're trying to find the reciprocal function, we flip it, right? That's all we need to do. So secant, if that's 1 over cosine, and cosine is the adjacent over the hypotenuse, well then secant is just the hypotenuse over the adjacent, right? And the same idea, if cosecant is just the reciprocal of sine, it's 1 over sine, well that just means I take the sine, which is opposite over hypotenuse, and I flip it. Now it's hypotenuse over the opposite side, right? And cotangent, if that's SOHCAHTOA, oh, I'm sorry, I messed that up here. I was going to blindly copying, it's O over A, right? So if cotangent is 1 over the tangent, which is opposite over adjacent, well, the reciprocal of O over A is A over O, right? We would just flip it there, right? So our process for finding these, if you notice, this whole unit's really, we're sort of building on little pieces where each lesson really just adds one extra piece from the lesson before here. So if we want to find the value for any of our reciprocal trig functions, we need to first know the value of our regular trig functions, and then we just flip them, right? So if P is the point -1/2, comma, radical 3 over 2 is a point on the unit circle, we want to create a triangle from these values here. Well, on the unit circle, let's just remind ourselves, means that cosine of theta is equal to the x-coordinate, and sine of theta is equal to the y-coordinate, while always tangent of theta is going to be equal to y over x. So let's create that triangle real quick. I'll do it over here. When I'm given coordinates of a point, I like to do it on the coordinate axis. So -1/2 is this way here. Positive radical 3 over 2 is, oh my goodness, is that way. So let's erase this here. Right, -1/2, positive 3/2. That's our point P. We draw our radius, which is from the point P to the origin. So that's -1/2. This is radical 3/2. And this radius, since it's all on the unit circle, just has radius 1 here, right? Remember, this is our, now we can actually use this language, our reference angle. So this is the opposite side, this is the adjacent side, and this is the hypotenuse, of course, right? And when we're on the coordinate plane again, the vertical side is always the opposite one. The horizontal side is always the adjacent one here. So we've created the triangle from these values, and now we want to find the value of each of these here. Secant of theta. Well, what we just learned is that secant of theta is 1 over the cosine, which is the hypotenuse over the adjacent side. Well, in this case, the hypotenuse is just equal to 1, and the adjacent side is -1 over 2, right? And we know how to handle complex fractions like this now from past unit, and this is just equivalent to -2. Cosecant, well, this is equal to 1 over the sine, which is just equal to the hypotenuse over the opposite side, right? So the hypotenuse here is 1, and the opposite side is radical 3 over 2. And this simplifies to 2 over radical 3, but of course we want to rationalize that. So we get that this is equal to 2 radical 3 over 3, right? Cosecant here. And of course, You might be thinking as well, like, well, if I have memorized the exact values, if I know the exact values for the trig functions, I'll just memorize these. That's like I've been saying, it's a bad idea to memorize those things. You want to always know that picture and sort of build up like the way we're doing here. Don't try to just remember that cosecant of whatever this angle would come out to be. I think it's 60 degrees in this case. Don't try to just remember that cosecant is equal to this value. You're never going to remember that. Build it up the way we're doing here. That cosecant, I remember that is 1 over sine. I remember sine is always opposite over hypotenuse. So the reciprocal is hypotenuse over opposite, right? And then I just work out the math from there. It's much easier. Anyway, though, returning to our example, cotangent of theta we also want to find. Well, we know that this is equal to 1 over tangent. Tangent's usually opposite over adjacent. So in this case, cotangent is adjacent over opposite, right? And our adjacent side in this case is negative 1 over 2, and our opposite side is radical 3 over 2. So those 2's will cancel out, and we get negative 1 over radical 3, which just comes out to negative radical 3 over 3. Okay? So that's how we can just use our regular trig functions to find our reciprocal trig functions then. And we can do the same thing for any of the types of problems we've seen throughout this lesson here, right? So we want to name the quadrant in which theta will lie. If it says secant is greater than 0, that means it's positive, and cosecant of theta is less than 0, that's negative. Well, if we want to figure out what quadrant that's going to be, we need to know what regular function these are going to be associated with. And just remember, taking the reciprocal of a number does not change its sign, right? So like if I just have the number like 3/5, right? The reciprocal of this is just 5/3. We flip it. The SIGN sign never changes, right? It doesn't change from positive or negative, which just goes to tell us that our reciprocal functions are positive or negative in the same quadrants that our regular functions are, right? So our strategy for this case is going to be, again, we need to know the regular trig function that they're associated with. So secant is greater than 0. Well, that happens whenever cosine of theta is greater than 0, right? The reciprocal of a number can only be positive if that number itself is positive, which means cosine of theta here, since it's associated with secant, has to be positive. Same thing, if secant's less than 0, that means the sine of theta has to be less than 0 here. And now we know how to solve this problem, right? We have our ASTC chart. I know cosine theta greater than 0. Here, that's going to be in quadrants 1 and 4. Sine of theta less than 0, that's going to be in quadrant 3 and 4. So has to be in quadrant 4 here, right? So just like before, to handle these, we just need to relate them to our regular trig functions, and that's a problem we already know how to solve. Same thing like with problem 3, sine of b equals 2/3. Find the value of the other 5 trig ratios. Well, it might not look like we have all the information here, but we've done problems like this. We've just only found sine, cosine, and tangent. We just have 3 more now. There's not that much work. We just take the answers we would have found and we flip them, right? That's always what we do. But anyway, we can set up a triangle based on this, right? So it says sine of angle B is equal to 2 over 3. So we always want to be thinking in terms of right triangles here in this case. Let's say this is our right triangle, and I'll say this is angle B. Sine is always opposite over hypotenuse. So I'm just going to take the number that's in the numerator, and that's going to be the opposite side, the one that's away from it. And then one that's in the denominator has to be the hypotenuse, because that's what the sine is, right? And of course, I don't have my adjacent side, but we remember from past lessons that in order to get the adjacent side, I just need to use Pythagorean theorem. A squared plus b squared equals c squared, where again, a and b are the legs of the triangle and c is the hypotenuse. So just make sure we get the numbers on the right side. Let's say we're solving for a here, a for adjacent, why not? A squared plus, we'll say b is now 2 squared, because that's one of the legs, has to equal the hypotenuse c squared, and the hypotenuse is 3 squared. So I have a squared plus 4 has to equal 9, or a squared has to equal 5, or a is just radical 5 by solving all that, right? So our adjacent side has a value radical 5 here. And now it's quite easy now that we have a triangle. We already know sine is 2/3, so let's say cosine of b now. Well, that's always equal to the adjacent side over the hypotenuse. The adjacent side is just radical 5, the hypotenuse is 3, okay? And tangent of b, well, that's equal to opposite over adjacent, so that is 2 over radical 5, or once we rationalize, we'll get 2 radical 5 over 5. And now we just need the reciprocal functions, but that's easy once we already have the values of the regular, right? So we'll say secant of b, well, that's 1 over cosine of b. If cosine is radical 5 over 3, then its reciprocal is 3 over radical 5. Or again, rationalizing, that's just equal to 3 radical 5 over 5. Okay, and same idea. Cosecant of b, CSC, is 1 over sine. It's the reciprocal of sine. Or if sine was 2/3, this is just 3/2. And cotangent of b is 1 over the tangent. It's the reciprocal of tangent. So if tangent's 2 over radical 5, which rationalized to 2 radical 5 over 5, then this is just radical 5 over 2 in that case, right? And those are all of our other 5 trig values here. So 1, 2, 3, 4, 5, right? So again, our strategy for all this is we need to break it down into a problem we already know. We don't know the exact values of reciprocal functions here, but we know exact values of regular trig functions. There's no special right triangle for just reciprocal functions, but we have a special right triangle that gives us sine, cosine, tangent immediately, and we can just use them to figure this out as well. All right, so let's practice a little more here. We want to find the exact value of cosecant of each expression here. So number 1, cosecant of 270. Well, the first thing is I need to remember what regular trig function. So this is going to be equal to 1 over cosecant is paired with sine of 270, right? And now I need to know what sine of 270 is. And the way you find sine of 270 is we use our unit circle, right? 270 is over here where the coordinates are 0, -1. And since we're on the unit circle, sine is just equal to the y coordinate, which is just equal to -1 here, in which case 1 over -1 is still just -1. And it's the same thing for any of these. So we can do, let's take a look at one of these. We just did cosecant, so let's look at one that requires a little extra work for everything. We're just going to have to do all in one here. So cotangent of -60 degrees. Well, the first thing is I don't really like negatives in my negative angles for that. So I'm going to go ahead and make this into one of its coterminal sides by just adding 360. We discussed that, right? So we know that this is equivalent to cotangent of 300 degrees. Okay, that's great. I still don't know what that is yet, but I know that cotangent is just equal to 1 over tangent of 300 degrees. Again, that's great, but I still don't know what that is just yet. So I need to now find what the tangent of 300 degrees is. To do that, I'm probably going to need a little chart here. And at this point, I know that 300 degrees is all the way over here, right? And I need to then see A, S, T, C. And I'm just going to sort of separate this out for a second. I'm just going to solve for tangent of 300 degrees, and then I'll flip it at the ends just to sort of keep my work more clear. So I know that this has to be equal to, since I'm in quadrant 4, it's going to be equal to negative tangent of whatever that reference angle is. That's what we talked about last lesson. And our reference angle is this one over here, which since we're in quadrant 4, the way I can reason this out is, well, to get all the way back up to here, I would have to go 360 degrees, but I've only gone 300, which means I just take 360 minus whatever my angle is, which is just 300 in this case, and I just get a reference angle of 60 degrees here, which should also make sense because we started out at -60. That means we just went backwards 60 degrees. It's kind of telling us there. Just our problem solving skills don't really remind us to just think about in terms of negative, so it helps to sort of add that 360 first. But getting back to the problem now we need to figure out what tangent of 60 degrees is. So we have our special right triangles for that case. All right, let's say that's 60, which means that this one's the 30, so we have 1, radical 3, and 2. Tangent of 60 is always opposite over adjacent, which is just equal to radical 3 over the adjacent is just 1, and there's the negative sign. So if tangent is just equal to negative radical 3, then 1 over tangent, bring this back over to here, is equal to negative 1 over radical 3. Or rationalizing this, we get radical 3 over 3. Negative radical 3 over 3, right? And that's the reciprocal. So after all of those steps, we end up that cotangent of -60 is just equal to negative radical 3 over 3. And then again, just to recap, the way we did that is first I put it in terms of the regular angles between 0 and 360 with the coterminal sides. Then I related cotangent to its reciprocal, which is tangent. Then I found the value of tangent of 300 with reference angles in my ASTC chart. All right, so just to keep it a little clearer, let's do one more. Let's do over here, let's just do number 3 here, cosecant of 180 here. Well, cosecant I have to relate to sine of 180 degrees. 180 is over here where the coordinates are negative 1, comma 0. Let's see, I don't know if we can see that, right? So I just drew this little coordinates here on the plane, negative 1, comma 0, sine of 180 is equal to the y coordinate here, which is just 0. So if cosecant is 1 over the sine of that, we get 1 over 0, which means this is what we talked about before, that cosecant of 180 is actually undefined in this case. All right, and that's perfectly fine. We can have an undefined value. So our strategy for these, again, is we just sort of break them down. There's one other way we can ask questions like this, and this is sort of a combination of stuff we've done here. This video is a tad longer, but we're not going to have one for the next lesson just because it's more practice. I just want to give you all the examples here. So sorry about that, but let's take a look at something like number 12. It says, for each of these given ratios, find the exact values of other 5 trig ratios in the same triangle here. When it says exact values, that also means we want to get whether it's positive or negative, right? But we just need to get back to our definitions in this case and understand that this is in relation to a right triangle. So remember that cosecant of b is equal to 1 over the sine of b. And if sine is always opposite over hypotenuse, and this is going to be the hypotenuse over the opposite side here. And we're just going to use that to sort of orient ourselves with the right triangle that we're going to draw here, right? The hypotenuse over that. But we also need to get the SIGNs right. So this is telling us that cosecant is negative, or in other words, that sine is less than 0, and secant of b is greater than 0. But secant goes with cosine, so that means cosine has to be greater than 0. So we need to find the exact values using this special right triangle that happens to be in, let's see which quadrant. Right, sine is less than 0 in ASTC. Sine is less than 0 in here and here. Cosine is positive in here and here. So that means our triangle has to be in this quadrant. So I'm just going to draw that little sketch. Right, this is the triangle we would get from that case. Remember, we're always drawing our triangles with the radius coming from the origin to our point there. And now cosecant, it tells us, is negative 5 over 2, which means the hypotenuse is 5. And the opposite side here over here is negative 2. And that should make sense because we went below the x-axis. We put the negative sign with the 2. Remember, we keep the radii here always positive, and it's either the x or the y that gets a negative, depending on that case. Right? And at this point, it's pretty easy. We need to find that third side. We're going to do that, of course, with just the Pythagorean theorem. So we have 5 squared should equal to negative 2 squared plus b squared, or 25 should equal 4 plus b squared, and we get 21 should equal b squared, or radical 21 equals b. Okay, and we can simplify this too. This is, let's see, can we? 7 and 3? No, we actually can't, so we're good there. So anyway, this is radical 21. And now we have all the sides of the triangle, so finding the other values of the trig ratios is easy. Sine of this angle is going to be equal to the opposite over the hypotenuse. So opposite here is negative 2. The hypotenuse is 5, or just the reciprocal of cosecant. That one's easy. It's basically for free. Cosine of theta is going to be equal to the adjacent over the hypotenuse, which is just radical 21 over the hypotenuse is 5 in this case, right? Tangent is equal to opposite over adjacent. So our opposite side is negative 2. Our adjacent side is radical 21. We rationalize and we get negative 2 radical 21 over 21. And the rest of these we already did cosecant equals negative 5 halves. We're given that one, so we need secant is equal to 1 over the cosine, or just hypotenuse over adjacent, which is 5 over radical 21, or rationalizing, we get 5 radical 21 over 21. And lastly, just sort of separate these, we need the cotangent, which should just be equal to a over O, excuse me, a over O, which is equal to radical 21 over negative 2, or just negative radical 21 over 2. Okay, and that's how we would handle all these problems. Again, it's a little longer video, but that's just because lesson 6 is more practice anyway, so I wanted to give you an example of how to do each one of these here. So that's going to take us to the end of lesson 5, and I'll see you for lesson 7, because lesson 6 is just extra practice.